Hello everyone, and welcome to the 10th and final lecture of this Python from Scratch course, in which we're going to talk about code quality, code readability, and general coding standards, which you're going to have to employ in your code if you're working in a programming team, and which I encourage you to use in your code even if you're coding alone, because it will make your life a lot easier. In today's lesson, we are going to go through several topics, several ideas which you need to keep in mind whenever you're writing code, which will help you in the long run, even if in the short run they feel a bit time consuming and not that useful. So first thing you want to think about is the program structure. When you're writing code, it has to be structured nicely, and there are three aspects of the code structure you need to take into account. First is modularity. You need to group code by purpose. If you're writing some piece of code, it has to be grouped depending on what it does. If you just have a file of random functions, sure, those functions might be useful, but if someone were to go into that file and try to find some information inside of it, they wouldn't be able to do it. It would be quite difficult. And even if you write a program, write that file and go away for a year and come back to it, you will find it very difficult to understand what that file actually does. But if you have separate modules, separate files for each particular task, subtask of the general problem, you will immediately know, oh, this file has all the functions which with regards to this, and this file has all the functions for a different functionality, and so on and so forth. Second thing you want to take into account is reusability. If you know that a certain piece of code can be used in multiple places, and then you by all means should take it out of the code and place it in a block which can be reused, for example, a function or a method inside a class. This way, whenever you need to do a well-defined task, you know where to go and find that piece of code. And if you need to change that piece of code at a later stage, you won't need to go looking around your code for every time you implemented it. You just need to find the implementation, you need to change it, and it will change everywhere where that piece of code is called, where that function is called. That's why it's so important if you notice a piece of code, a block of code, which you are reusing, take it out and put it into a separate function, separate block. And third aspect of program structure you need to take into account is extensibility. It is quite common when you're given a task that you have solved it and it works great, but then you realize you need to extend it, you need to add some functionality to it. And it's very important for you to think about it ahead, so that when the situation arises, you can easily extend your code and you can easily add new features without having to completely redesign, completely think from scratch on how to solve the problem, because that is very time consuming if such situation arises. And it is actually very common. It is, as far as I'm concerned, it happened in every programming project I have ever done. So if you are working with a client will look at your code you have produced and look at the solution you have produced, and then will say, oh, it's great, but can it do one extra feature, and can it do this? And then you'll have to add that feature for your client. So make sure you think about that. The second topic I wanted to talk about is robustness. We need to make sure we write robust code that doesn't break, that works exactly as we expect it to. And several things that are on the slide we haven't learned yet, for example, exception and error handling, but you will learn it at the later stages of your programming career, because exception and error handling is such a fundamental part of programming that is present in almost every programming language. So first, let's have a look at sensible parameters. What do I mean by that? If you have a function, if you have a block of code that's taken out of the main code execution, you need to make sure you only pass the required parameters to it. Don't pass like 10 different values, 9 of which are not used. Think about what this function, what this method actually needs, and pass it exactly that information and nothing else. Because if you're passing more information to it, you're just wasting computational energy for nothing, and you're making your program less efficient. And it is, again, more difficult to read for a person who's going to read it afterwards. They're going to look at your functions, they will see 10 different parameters, 9 of which are not useful, and they will just ask a question, well, why are they here? And obviously this also helps with testing, which we also haven't learned yet, but as a programmer, you will need to write tests for your code. You will need tests enable you to make sure that your code executes exactly how you expect it without you having to go through your code yourself. As the code gets bigger, it will become almost impossible for you to go through your code and quality assure it, because it's just too big. That's why the larger code gets, the more need you will have for automated testing, which will ensure that your code performs exactly how you expect it to. And the second point here is use classes to group variables. Again, that goes to the modularity argument from the previous slide. Everything that's related to each other should stay close, in a close proximity in your code, and everything that's not related should be separate, so that you know exactly where to look for material you're looking for. And second point on the slide is graceful failure, which we haven't learned yet, but the concept we can talk about right now because it's important to understand even at this early stage. In programming, things go wrong. That's just a given. No matter how good your program is, something might go wrong. A user might give an input you didn't expect, and so on and so forth. And it is much better if you're expecting something to go wrong to handle it rather than let Python handle it. Because if Python catches an error, they will display this error message, which for an average user is quite scary and they will get confused. But if we know that such a situation can occur, we can handle this error, we can handle this exception, and we can say, oh, if a certain type of input was given by the user, we will return a sentence saying, you cannot write strings here, it must be a number, for example. And that way it is much more user-friendly, and user will have a much better user experience using our code. So make sure you think about error and exception handling when writing your code. Third topic is technical proficiency. And what do I mean by that is you should use the property features of your programming language which are available. Just because you know how to solve a problem in a particular way, it doesn't mean that way is the best for your for the scenario you're currently working on. Obviously, programming languages constantly change and new functionalities is introduced, and you shouldn't always look for a perfect answer. Sometimes it is good enough to just find an answer and use it. But if you do have a knowledge of different aspects of programming language, it is important to think about, which aspect of the programming language is most appropriate in this particular situation. And I just dropped down a few quick examples from what we have learned so far. For example, lists versus dictionaries. You need to think about what information you're storing and how you're going to access it. And will you need to sort it, and so on and so forth. And depending on the answer to those questions, you can make a choice of as a list or dictionary is a better data type for your given problem. Same for standalone functions or class methods. Is it a function that's not related to anything, or is it a function that's related to a particular class? Exception handling, again, you need to handle exceptions and errors in your code, because if your code returns errors to the user, they will not like the experience they are getting. Loops versus repeated code. If you know you will have repeated code in your program, it is you need to use loops, otherwise your code will become extremely unreadable. So as you can see, all of these points kind of tie nicely together. Make sure you explore different aspects that the programming language is offering you, and obviously for larger projects you can even explore different programming languages to incorporate into a single project. For example, TypeScript offers a very useful functionality called decorators, which basically allows you to call a function before another function call, or call a function before a class implementation, and so on and so forth. And if that is something you're looking for, it might be useful to bring TypeScript into your project. But that is again something you will be able to make better decisions once you learn more about programming in general. Fourth topic is readability. Again, readability is extremely important whether you're working alone or not. If you're working alone, you will write a piece of code and then you will go away. And if you ever come back, you need to understand what you have written. Otherwise, you will not be able to continue working on the code, or it will take you extremely long time to figure out what on earth is happening in your code. And if you're working in a team, it's literally a necessity for you to write readable code. To write readable code, you need to think about consistency. So use the same formatting and indentations throughout the entire project. So for Python, indentation is kind of forced. For for loops, there's 4 spaces or 1 tab. But for a different programming language, it might not be forced, but you still need to think about it. And if you're using an integrated development environment, it will usually help you with that. But if you're using something like just a text editor, you will need to remember that as well. Just make sure your code is always consistent. Second point is your code should be self-documenting if it can be, and if it can't, then you should add comments. What do I mean by that? Self-documenting code is a code which you can read and you can immediately know what's happening and why each variable, why each function is called, where it's called, what it does. And the best way to do that is using descriptive names for variables, functions, methods, classes. So if a function does the sum of 2 numbers, this function should probably be called sum. If you called it x or sofa or a tree, when someone reads it, they will be like, well, why is it a function called a tree? It does a sum, right? But if it's called sum, they will not need to go and look up for definition of the functions. They will immediately know that based on the name of the function that this function does a summation of 2 arguments passed to it. So make sure your code is as self-documented as possible, as clear as possible, without having to write comments. And the third point is choose a naming convention and follow it. So there are different naming conventions. You might have seen Pascal case, you might have seen camel case, you might have seen me doing name underscore name, and so on and so forth. There are many different naming conventions. You can kind of choose whichever one you like, or you need to follow the ones that's used in your team. But you need to choose it and you need to follow it. So if some of your classes are defined within Pascal case, and then some of them are defined in camel case, and some are defined with underscore, it gets super confusing. So each type of your programming language, each part should use a particular naming convention. So classes, Pascal case, for example, methods and function names, and variable names, camel case, and so on and so forth. So that way you will immediately know whether you're dealing with a variable or whether you're dealing with an object or a method just by looking at its name without having to look further deeper into it. And fifth and final slide I want to discuss today is commenting and documentation. We are going to focus more on commenting in today's lesson, and documentation I will just briefly discuss. Commenting is text in your code that Python ignores, and any other programming language will ignore as well. And it's just there to make your code easier to understand, or it's just there to explain your code. But you need to make sure your code quantity and code quality are exactly right. You do not need to write comments if the code is self-documented. So if you have a line that says variable name equals something, you don't need to add a comment about saying initialize variable assign some value to it, because it is self-explanatory. Anyone who has any programming experience will be able to look at it and will immediately see that a variable is initialized and some value is stored inside of it. You need to write comments if you need to explain or justify any non-obvious decisions. So that's usually with regards to design decisions. You might look at a problem and you might have an idea of how to solve it, and then you try to implement it, but you realize that it doesn't work for X, Y, and Z. And then you solve it in a different way, but you will add a comment explaining, oh, I tried to solve it using X, Y, and Z. I tried to solve it using the first solution, but it doesn't work for X, Y, and Z, and that's why I have implemented it this way. That way, when another programmer looks at your code, they will know why you have chosen that design decision. And just a general rule of thumb, you need to comment anything that another programmer would not understand. If you look at your code and it is as self-documenting as it possibly can be, but it's still quite difficult to understand because it's quite complex code, you need to add a comment explaining what it does. And that's about code quantity. And in regards to code quality, as I said, do not restate what the code already says. If it's self-documenting, leave it as it be. Comments must provide additional information. They must extend, they must make your code more readable. And when you're writing comments, you don't need to explain the code itself. You need to explain what the code aims to achieve. So you have to take another level of abstraction, take a step back and look at what the code is actually trying to achieve. What is its goal rather than the algorithm itself. Anyway, that's all I want to talk to you about today. Make sure you keep in mind all of these things when you're writing your code: program structure, modularity, reusability, extensibility, robustness, sensible parameters, and graceful failure with exception and error handling, technical proficiency. Always keep exploring different features of your programming languages and maybe even explore other programming languages. Readability, make sure your code is consistent, make sure it's as self-documented as it can be, and make sure you choose naming convention and you follow it. And make sure your code is well commented. Oh, that actually reminds me, I forgot to speak about documentation. So what documentation is a separate piece of file which explains how your code works. So for example, for APIs, you will usually find API documentation which explains how you can use that API to get the functionality and the information you need. And documentation is just a file which explains how the code works. We haven't seen that in this course, and because we obviously have been writing a rather small piece of code which don't really require documentation, but obviously as the code base grows, it becomes extremely difficult to navigate. And documentation helps you understand which parts of the code base work, how they work and what they do. And documentation usually allows you to understand code at different levels of abstraction rather than at the lowest level of the code itself. It will tell you, oh, this code blocks, these few files carry out this functionality, and that's how you can use it in different part of our code base. There are different documentation tools that help you write documentation. For example, JSDoc, which I use quite often. So what JSDoc does, it has a certain format which will automatically create documentation for you if you follow it in your code. And it's extremely useful, but there are others, so you feel free to explore other documentation tools out there. Anyways, that concludes the 10th and final lesson of this Python from Scratch course. And it may feel a bit weird finishing so quickly, just in 10 lessons, but you are a programmer now. You know all the basics of programming, and you have learned that through Python programming language. So even if you feel like you're not sure how to solve certain problems just yet, it's completely fine. That's a normal feeling. Just keep working on your code, keep learning new stuff, keep practicing all the skills you already have, and you will see your programming skills develop very quickly. That's all I want to talk to you about. I just want to say I'm extremely proud of you, and good luck in your further programming career. Bye.